So I didn't originally intend on making this video because there's so many on YouTube videos of people showing how to do this kind of stuff on their graphing calculator, but I didn't feel like any of them really hit exactly everything that I felt like one reasonably should. So I'm going to do a little bit here, since yeah, again, none of the videos on YouTube felt like they would be like 2 minute video when it really should be more like 6 or 7. And then there'd be, I found one video that was like an hour and 10 minutes. And I'm like, okay, I'm not going to expect any of them to watch that. So anyway, here's a little bit of a review video to help us get more familiar with this example. So here we say the yearly profit is given by this function P of n, and it is defined to be negative 180 plus 100n minus 4n squared. And it gives us the output in thousands of dollars when n 1,000 units are sold and n is between 0 and 20. So the first question says to sketch and label the graph. So we immediately right away know that we are not going to try and figure out how this function is supposed to look on our own. We're going to go to our graphing calculator to know what the graph should look like. So I'm going to switch to that application that I have. Please ignore whatever ads this is giving me. So I click, I want to input my function into the calculator. So I hit y equals, and it pulls up the list of functions that I have here. Now, I only really care about one function at a time for this kind of question, so I'm just going to type it into y1. So y1, I want to be equal to negative 180 plus 100 times n. Now, again, our calculator doesn't know how to handle different names for inputs, so our calculator only knows inputs as x. So I click the button right beside alpha with x, comma t, comma theta, comma n. And that's just always going to be what we click to refer to our input. So even though the function in the book says n, and how we're going to talk about our inputs is calling them n, our calculator is only going to handle x as our input. So we have negative 180 plus 100x minus 4 times x squared. So now that we want to square our input variable, we have two options. We either hit this arrow to put us up there, and we can type in 2 while we're up there, or let me hit delete on that, or we can hit, since we're just squaring, there is a button right above log and right below the x to the negative first that is x squared. And that will just always do a square. Now, sometimes we need to type in, so let's say, for instance, I wanted to say x cubed, sorry, plus x cubed. Now, there's no button to just put a 3 up there, so that's when I really do have to use the arrow to go up here and type in 3. So on an older calculator, like how I have, it won't have you typing up there. It'll just do the caret. It'll literally put arrow as like a symbol, and then you type in whatever you want to go inside the arrow, like with parentheses. So I'll do more examples in class if you need to see that, but just for this function, we've done all that we need to. So negative 180 plus 100x minus 4x squared. It is exactly like what the book tells us, except we're using x's instead of n's. So always good to double check your answer there. Now, it tells us that, well, when we want to do a graph, one of the most important things to do is what kind of graph do I look at? Where am I looking at this graph, right? Because the domain for so many of these functions are from negative infinity to infinity. So there's an infinite number of possible windows that we could look at. What if it was negative 1 million to negative 999,000? What if it was 2 to 4, right? They're very different options. And so we have to think about, in our context, what window do we want to be looking at this graph at? So we hit window so that we have control over where we're looking at with our graph. So the X-min, X-max, Y-min, and Y-max are going to be the only values that we're going to touch in this list. All of these things like X scale, Y scale, those should always just be one. We never want to change those. We're only going to change X-min, X-max, Y-min, Y-max. Now, this question tells us that n is between 0 and 20. If we look back to what I have written, n is between 0 and 20. So I know that for my inputs, again, because n is our inputs, that the window for my x values should be 0 as the min, 20 as the max. So I'm going to go to my window and type in 0 for the min, 20 for the max. Now I can click on graph to see the kind of graph that it tries to draw for that. Well, clearly this doesn't look good at all. And so this is very hard to tell what's going on here. This almost looks just like a regular straight line, much less the kind of parabola that we know that this kind of question should be. And if you don't know it should be a parabola, that's okay. That's not something that this class is trying to touch right now. But as something with x squared, it should not look like a line, is my point. So now we're going to do something that we're almost always going to try, whether we think we need to or not. So even if you look at this and you're like, sure, I guess, why not? It's still very, very good practice to always do zoom fit. So my point right now is that while we know, I don't know why I said it like that, while we know that x should be between 0 and 20, we don't really know what our y value should look like. So in order to fit the y values on the screen, I'm going to click zoom. So I'm looking at the graph right here. At the top row, we have y equals. That's where I typed our function in. We have window, where we typed in the window for our function. And then we have zoom. So I'm going to click zoom. And then we have a lot of options here. Zoom in is very basic. It just zooms into wherever you choose. Zoom out is, again, just zooming you out. Decimal, I don't know what that is. Square just kind of fits you into a really basic square. Standard is from -10 to 10 in both x and y. So a good way to kind of start over if your function just looks weird and you just did something else would be to do zoom standard. But here I know that my x's should be between 0 and 20. I already set that. I don't want that to change it. So for that sense, I need to fit the graph in between whatever y values. So zoom fit will always keep your x values and change the y's to fit where the graph should look like. So I'm going to do zoom fit and it automatically change the y values in my window to be reasonable and good. Also, it changed the x max to 21. I may have just typed that wrong and didn't realize it until now, but either way, sure. Now, oh, it also changed the minimum to -1. I think it just added one on the left and right to kind of give us a better vision of what we're trying to see. So why not? I guess that's fine. But just know, as far as the questions that it asks us, we only want to consider inputs between 0 and 20. So I guess we'll do -1 to 21 if it says. I don't think most calculators did this. I don't think my actual calculator does that. It's only this app that I have that did that. But okay. Now we see a much better picture of what our graph is supposed to be. I see that my function goes from 0 to 20, but it also goes up really, really high and goes really, really low as well. Well, as far as needing to draw my graph, it's kind of helpful to know exactly what those values are supposed to be, what that max value is and what that minimum value down there is. Because if I go over here and draw the shape that it just made, then I do something like this, that certainly isn't enough for me to be able to read or glean any significant information from this graph, right? I need to label the graph. I need to add the relevant information. So first of all, we need to say, well, what axis is what? How do we know what is our input and what is our output? And in our case, the input is always going to be the horizontal axis. So in this function, we call our input n, and we call our output p, and we can even write p of n to let us know specifically we're plugging n to our function there. So that's just labeling the axis. That's always routine and standard. Input variable, output variable. Input right there, output right there. Just very standard. Oh, I opened up a different document. Okay. So that's very standard when we label our axes. Next, we want to actually mark what points are what. Because if I said, well, what does it look like when n is 2? You don't know where 2 is on this graph. So we need to label the axes, the points along the axis. So here, because of what the question told us to do, our graph goes from 0 to 20. So I know that I need to have my input labeled here. This is 0, and this is going out to 20. But that doesn't tell us anything about our y values. In fact, when we go to our window for our y values, it tells us the y minimum should be negative 211, and the maximum should be 476. Now that is a different value than what I got earlier and what we did in class. So that is, I think, an example of just the window trying to really like stretch out and maximize this view, right? Because if it only went up to the actual maximum of the function, then that's not really a good picture, right? Like if I just cut off this top portion of the, oh, did not mean to do that. If I just cut off the top portion of the graph, it wouldn't really look quite right. Okay, so let's label. We'll look at our window here and label the graph based on what it said for there. So it said that this top value that it's giving us was about 400 and was it 75? 76, I'll call it 75. And this bottom value for the negatives, it said was negative 211. I accidentally opened right back to that. So this number that it went all the way down here, negative 211. Maybe we even call it 12 to round it, even better. Okay, this gives us a way of actually reading and interpreting this graph. Now I know if I said plug in 10, do you know where you are about at? Well, yeah, 10's about right there. So we look about there, and sure, that means something to us now. Very good. Okay. So that's as far as sketching and labeling the graph as I intend to do. Now we want to calculate and interpret p of 0. So in this function notation, that just means plug in 0 to our function. Well, to calculate it directly, our calculator is actually very good at knowing function notation. So if I just quit back to this regular main menu, if I were to type in y1 of 0, I could evaluate that. So let's do that. So let's go to variables, this VARS right beside clear. I hit that button, and then I want to access my y variables. So I'm going to hit the right arrow key to go to the y variables, and it pulls up this menu. Now I want to access my function variables, so I'll hit enter on that option, and now it pulls up the list of y variables, the list of functions that we have. So because I named my function y1, I'm going to hit enter, and it will type in y1. Now again, what I'm saying is our calculator knows function notation. How do we draw this out? We write the name of the function, parentheses, 0. And this calculator knows how to handle that exactly. y1 of 0 is negative 180. So that is how we can calculate these values for our functions. y1 of 0 is negative 180. So when I plug in 0, I get negative 180. So that is how we can calculate it, but this question also asks us to interpret what that means. So when we interpret, we are saying what does the input mean in reference to this output? So negative 180, well, the outputs of this function are thousands of dollars is the profit after selling 0 units. And I think that makes sense. If you haven't sold anything, should your profit be positive? No. You haven't made enough money. You haven't made any money. You have only ever spent money to try and make and produce this stuff. So negative 180 thousands of dollars is the profit after selling 0 units. And technically, I left something out that is fine in this case. It should really be 0 times thousands of units, right? Our inputs are in thousands of units sold. Well, 0,000 units is just 0 units, so I didn't want to include that. I didn't feel the need to say 0,000 units, and you don't really have to. But even if you did say 0,000 units, I think that's perfectly fine. I'm not even good practice, albeit kind of redundant in the larger context of things, but it's fine. You could say 0,000 units, and that's fine. But really, that just means 0 units. Okay. So now it says, what's the profit at 15,000 units sold? So this means we need to figure out what number to plug in to our function. Now, this is a little deceptive the way that I wrote it, because when I say, what's the profit at 15,000 units sold? You would be tempted to plug in 15,000 into our function. But we need to remember, just like I pointed out, we're n is already 1,000 units. So in this case, at 15,000, n is just 15. So we're not going to plug in 15,000 into our function. We're just going to plug in 15. So again, I go to variables, y variables, functions, y1. And then we look at our function notation. We just do parentheses, y1, parenthesis 15, close parenthesis, and I hit enter, and it says 420. So now our output here at 15,000 units sold should be 420. But again, our outputs is yearly profit in $1,000. So the profit at 15,000 units sold is $420,000. And you can write that out in words. You could say $420,000. You could write it as this number. You could write it even just with the dollar sign. $420,000 is perfectly fine. All 3 of these answers are, of course, saying the exact same thing, and you can say it however you want to communicate that information. Okay, so now this question says approximate the break-even point. Well, let's think about what the break-even point is in terms of the function that it gave us here. It's giving us a function for profit. The break-even point is where we're not making any profit. It is the point where our profit is exactly 0, when revenue matches the total cost. Well, that's just when profit equals 0. So really, it's meaning, this is just asking, find the input in where profit is 0, aka find the n such that p of n is equal to 0. So find the input where profit is 0. Find the n where p of n is 0. Well, if we look at the graph of our function, we can certainly see that, yeah, there is a point where this function crosses the x-axis, where the output is 0. It should be about right there. Now, my calculator is kind of smart enough that I just click near it and it immediately tries to tell me the 0. But by no means is that something that most any calculator will do. This is an app, not a real calculator. So in order to find the zeros of our function, this is the same as how we find zeros, maxes, or mins. We're going to we need to access the blue calc button. So we look between zoom and graph, right at trace. Right above trace, we see calc in blue. So I'm going to hit the second button to access the blue options. So second trace pulls up this menu of different options that it can calculate. Now, value just is plug in whatever value. So that's just find the output at a given value, which we're able to do other ways that are, I think, simpler. 0 is to find the zeros of our function, the inputs that give us an output of 0, which in this case is what we want. Now, minimum and maximum are going to be finding local mins or maxes. So looking at a specific area of the function, and it will tell you what the maximum output and the input corresponding to that is going to be. And like same thing for minimum. The intersection is when we have two graphs that it will draw, and we can figure out where the intersection points are. And 6 and 7 don't exist as far as this class is concerned right now. So ignore 6 and 7 entirely. 5 is for 5 is for 1.6, but for right now we care about 0, min, and max. But specifically for this question, we only care about 0. It wants to know the break-even point, where the profit is 0, and that is exactly what 0 will try to do. So what we do, I selected 0, and it brought me to this picture of the graph. And we can see this question up here. It says left bound. So it is asking me for, essentially, it's going to make a window that it is going to look for between to find any zeros. And this is going to be the same process for maxes and mins, but I'm doing it in terms of zeros. So it asks for a left bound. So I'm going to go to the left of where I see that 0. It's going to ask for a right bound. So I'm going to go to the right of where I see that 0. And it's going to ask, if you have most of our calculators, it's going to ask for a guess. At which point we would just select a value in between the two bounds and just hit enter, and it will find the value. Now, my calculator doesn't care to ask for a guess, and in fact, it immediately tells me what the 0 is. So I gave the left and right bound, and it told me right away what the 0 is. So it says right there, 0 x equals 1.95249. So the 0 is at n, because that's our inputs for this, 1.95, and that said 249, blah, 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 blah. But per the rounding guidelines for our class, we're going to round to 2 decimal places. So we would say n equals 1.95. So that's what it means in all of our function stuff. But again, we want to put our answers in the context. It says approximate the break-even point. That's saying how much do I have to sell to break even. That is not saying at what input of the function do you get an output of 0. That is how we figure this out. But again, it says the break-even point. That is in the context of this function. So we need to say what this really means. So we would say 1.95 thousand, I misspelled thousand units sold. And again, you can write that as 1,950 units sold if you want. Either way makes sense. So again, that's a small detail to say you have to add 1.95 thousand units sold, but it is, I think, very important at some point. Okay, so that is how we find the zeros of our function, and oftentimes these kinds of questions kind of have a lot of context around what the 0 actually means. So in this case, it says approximate the break-even point. Let's say the question was talking about a population. Let's say the function was a population, and it said find where this species goes extinct. Well, that's when the population is 0. So again, there's many ways that you're kind of phrasing find the zeros, and it really just solely depends on the context of the question. And you kind of have to think creatively around what does this mean as far as the function notation, the algebra going on here. And now this last question, what is the largest profit possible? Well, we can look at the graph of our function. We can look at the graph of our function and see that that largest point does happen kind of at this hump, right? Kind of along here. And again, math calculator is spoiling the fun for us and telling us the max is right there. But let's say it didn't say that because again, most of our calculators don't. So let's go to that menu again. So we hold second and trace, and it pulls up this menu. And we want to find the maximum. So once I hit maximum, it's going to, just like with the zeros, ask for a left bound. So I am just going to put my left bound somewhere to the left of where I see that maximum, and the right bound somewhere to the right of where I see that maximum. And then your calculator will ask for a guess, and again, just kind of select a point in between the two, and I can hit enter on the right bound, and it will immediately say, okay, I found the maximum between those two bounds, x equals 1.25, y equals 445. Now with our zero, it didn't tell us a y value because the whole point is that that is where y equals 0. Here, the x and y value are meaningful because going in, I didn't know what y value I was looking for or what x value I was looking for. I just said, where is this function the biggest? And it found the output and input corresponding to that. So what is the largest profit possible? Our calculator says y, that output is 445. So we would write $445,000 is the largest profit that this company was able to make. So the interesting thing here is that they could ask, when does this happen? Or how many units do you have to sell for that? Now, this question didn't, which means we fully answered the question already. But they could add on at what input does this happen? And that's when we use the x here. So it said x equals 12.5. So I'm going to add in parentheses here because it didn't ask for it, at 12.5 thousand units sold. So that would be if they asked us when this happened. But in this case, they didn't. So in this case, this $445,000 is the complete answer. But they could also ask, when does this happen? And we would say at 12.5 thousand units sold. Great. So we fully answered this question in the notebook, but there's a couple more things that I kind of want to talk about. So this question was really nice because it told us exactly where to look for our inputs. It told us n was between 0 and 20. This does not always happen. In fact, only maybe half, if not less, questions actually tell us where to look. So if we don't know where to look, then we're going to have to experiment a little bit with our window. So when I go to Zoom and I do Zoom standard, that just puts us back to the normal standard window. -10 to 10 for X, -10 to 10 for Y. And this is standard and a good place to start if you don't really know what's going on, if you don't have a larger context to what's happening. Now, sometimes our functions are very particular, right? Let's say it's talking about time. Well, does it make sense to have negative time? Not really. So in a case like that, our minimum would generally be 0. Now, if you're really not sure where to look at, you can always do this standard window, -10 to 10. And then you can go to the graph and say, okay, that doesn't look very good. And we can go to our zoom button. Again, the zoom button is always adjusting the window to give us a better picture of what's going on. And I can hit zoom out. Well, now we can kind of tell, oh, it zoomed out a bit. We can go to window again, and now it's -40 to -40 for X and Y. Well, that doesn't look quite exactly everything that I want to see. So let's zoom out again. I'm getting an ad. Okay, I have never gotten an ad for this. Okay, here's an ad, I guess, for some AI cheating tool. Okay, ignore that. That is not university sponsored in the slightest. Ignore that entirely. Okay, so now we can see here that we've watched our ad and zoomed out a bit. That we're getting a better picture of the function, but it's still not quite everything that we want to see. However, there's a lot of wasted space per se with what's happening with our x values, right? So now we kind of get this idea of we're wasting so much space on the x-axis with getting so little out of it. So let's go to our window and kind of change our x values again. So let's make this maybe -50 and 50. Okay, and yeah, that looks a lot more reasonable, a lot less wasted space there. So now we can go to our window and again, zoom out even more, and oh, perfect. Now we kind of see this tallest point that our graph goes. And then again, we're wasting a lot of our X space still. So let me change this again to, now we notice there's nothing really happening to the negative, so maybe I can make this 0. And for the maximum, I didn't really go too much past 50, so maybe I make this 50. Oh, 50. And yeah, that looks a lot more reasonable as a graph. So for that sake, we do kind of want to mess around with the zoom options a little bit, but it is kind of a guessing game. And I really hate to say that, but it's something that you just have to practice doing. Practice these questions and figure out, how do I adjust my window? When do I need to do this? Experiment and learn what does and doesn't work for different situations. So again, the zoom options are really good for kind of doing these really basic principles, but going to our window, we can manually change what these X and Y values are supposed to be. Great. So I think that is pretty much everything worth saying for that side of things. So I'll call it here. Very good. Hope this made some sense. And again, that ad is not endorsed by OU or myself at all. That is definitely something that goes against academic integrity and honesty. Don't use AI tools in class unless the class says to use them. I guess you could use it to study in some sense, but don't use it to cheat on your homework, because then you won't know what's going on if you only knew what the AI tool told you. If you didn't notice, a lot of teachers right now are pretty scared about AI and what that means for students. Because now what used to be a student turning in a blank answer on a homework assignment, they're just going to be turning in what the AI chatbot said to turn in. So instead of just automatically getting a 0, I actually have to read the question and try and discern their understanding. And then they're using words that they wouldn't normally be using for this situation, but are technically true. So it's just a scary time for teaching and grading with AI stuff going. It's easy to teach with AI's presence. It's hard to grade with AI's presence. And it's not really even intelligent. It's just pattern recognition, repetition. So and that's a brand. Okay, I should have ended this a minute ago. Sorry, goodbye.